we will compute this limit n tends to infinity of summation k over n squared plus k squared, and we want to write down as limit of a Riemann sum. Use this hint. In order to compute this limit, they write down as limit of Riemann sum of a function. So instead of compute the limit directly, we compute the integral. So here's the idea of the hint. We need to write this down as limit of Riemann sum, which gives us integral from a to b of a function f of x dx. So we need to figure out f of x. In this case, we will look at f of x where a and b are 0 and 1. A 0, b is 1. And delta x 1 over n, b minus a over n. So here's the idea. This definite integral is the area under the curve f of x. We have assumed that the curve looks like this, y equal to f of x, and we want to compute area under this curve where x between a and b. In our case, we will have 0, 1 here. X from a to b, or 0, 1. And to compute the area under this curve, this area, we will cut it into n thin rectangle. Say I cut it into those rectangles. A equal to x0, and then you have x1, x2, and so on, xk, and b equal to xn. We write dot 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 here, and each of the rectangles, so let's look at this one. This rectangle, the width is delta x. The width of the rectangles, this length, delta x, and the height of the rectangle, this length, is a distance from this point and this point, which is f of xk. So the area of one rectangle, so we pretend that this one is one rectangle. So when delta x is small enough, it tends to 0. This one, we can think of that as a rectangle. Area of one rectangle is the width multiply the height. The width is delta x, the height is f of xk. And take the total area, sum of all area of those rectangles gives us the interval a to b f of x dx. So summation k from 1 to n. So we have n points x1 to xk here, correspond to n rectangles. Area of summation of area of rectangles, f of xk delta x, and we let this limit n tend to infinity. That's why delta x tend to 0. We have dx here. So you look at this one, this is what they mean by all this hint. Summation of this interval from 0 to 1. A is 0, b is 1, f of x dx. Now we will use all of this data to find out f of x. Summation of this one. Here how they do it. Summation k from 1 to n. We want to create delta x and f of xk. Delta x here, 1 over n. And to have 1 over n out there, we will need n extra here. So n times k over n squared plus k squared. So we have delta x already. Delta x 1 over n. The whole thing here is f of xk. Let's write it in nicer form. So first I will write as n as 1 over n over 1 over n square. So 1 over n multiplies n square will give us n, and the rest k over n square plus k square multiplies 1 over n. Now this one is written as k from 1 to n, k divided by n over n square divided by n square, which is 1, k square over n square. So k over n whole square times 1 over n. The entire things here, we think of that as f of xk. F of xk, k over n divided by 1 plus k over n square. Here we know that delta x is 1 over n, and xk is k over n. xk is k over n because x1 is 1 over n. Each one of this is of length 1 over n. x2 2 over n. xk is k over n, and therefore f of xk is here xk over 1 plus xk squared. So our f of x, the function we are looking for, is x over 1 plus x squared. So the summation we have at the beginning, this limit, so this limit here will be the limit n tend to infinity f of xk summation f of xk delta x k from 1 to n, and let n tend to infinity. This one is an integral from 0 to 1, from a to b, 0 to 1, f of x dx, and f of x is 1. F of x is x over 1 plus x squared, x over 1 plus x squared dx. And now you compute this integral. Let's do substitution. Let u be 1 plus x squared. So we have du is 2x dx, and I need to change the limit of the integral. When x equal to 0, u is 1 plus 0 square, which is 1. When x equal to 1, u is 1 plus 1 square, which is 2. So this integral here can be written as integral from 1 to 2. X dx, x times dx is du divided by 2. Du divided by 2 multiplies with 1 over u. So du over 2u. 1 over 2 outside, 1 to 2 du divided by u. So this one is 1 over 2 natural log of absolute value u from 1 to 2. 1 over 2 ln 2 minus ln 1. ln 1 is 0, so 1 over 2 natural log of 2. And that is the answers for this limit of this summation. Natural log of 2 divided by 2.